Alright, nerds, so we've covered reflection, and now we're going to go with refraction, and let's hope we can get through this in a short enough amount of time. Okay, so first off, refraction is when light changes direction, or it bends, basically, as it passes from one medium to another of different optical density. It just means different density. Still, light can still travel through it, but so air is less dense than glass, for example. Okay, just the particles are closer together. All right, so refraction of light. Here's a few definitions. Optical density is the material, it's the ability of a material to allow light to pass through it. So incident ray, in this case, is this one. It's the first medium. So what it's coming, you see here, it's coming straight out of the ray box. That's the incident ray. This is the refraction ray or the refracted ray. The normal is the same. So here the normal would come off on an angle like that, and here the normal would come down an angle like that. And again, perpendicular to the surface. Where the two different subjects meet, the angle of incidence is that there, and the angle of refraction is there. These are similar to the ones in what are they called? Reflection. All right, so let's go for an example. So when a ray of light enters a denser medium, it bends towards the normal, and when it enters a less dense medium, it bends away from the normal. Okay, so here it goes from air to glass. Okay, there's different density. See, it bends towards the normal, so and away we go. Okay, and here theta I or angle I. Remember, we'd still prefer the term theta, which is that one. That was pretty rad. Theta I will be less than theta R, and here from denser to less dense medium, it goes along the glass, boop, 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 and then it bends away. Now, if you put that beneath that, you're going to see something pretty rad. But in this case, theta R, so will be greater than that, theta I. Okay, so refraction of light. Basically, ray of light bends towards the normal when it enters a denser medium at an angle, and away when it enters a less dense medium. By the way, if it comes, what was this? This one says no. Go back. If it goes straight down and enters directly along the normal, there's no bending at all. It just chills. It goes straight. Okay, so dispersion, separation of light. Basically, white light is made up of all of the other lights together. So when it bends, the different wavelengths bend at different angles because they're different. So they're not traveling together. So this is when they interact with a prism or diffraction grating. Don't stress about that, but that's just something that makes it bend. All right, so rainbows are when light separates into different colors. We love rainbows. They enter raindrops, and because it's kind of roundish, they go and it comes in. And the red light's refracted less than blue, so it comes down the bottom. It doesn't bend as far, whereas the blue bends more and it scoots out the top, and you get a rainbow like that. It's pretty. All right. So lenses. Refraction is really important with lenses, both with glasses and eyes, and anything else we use lenses for, which is heaps. These are different. Take a few seconds now to draw this, please. They're really important. And basically, we're now going to talk about converging and diverging lenses, or convex lenses, and what are they called? Concave lenses. Okay, so here it goes down, and you've got the focal point there, okay? So that the lens come in, and they all bend because the normal is off on a tangent, and it's up like that, so it bends according to that, and that's how you get your focus. Okay, so an incident ray traveling parallel to the center. This is the center ray here, by the way, because it's the one that doesn't bend because it comes in directly along with it. Will bend towards the center ray as it passes through a convex lens, and they all converge at the focus. So incident ray, which passes through the center of the lens, will so that's this one here, will go straight ahead. So eventually they will all meet at the one point. Okay. Concave, it's a little bit different. So an incident ray traveling parallel, again, to the principal lens, that's the principal ray, that's the center one, will bend away from the normal, up this way, okay, that way. These rays, you can extend them back towards the focus. Okay, so the focus is here. So basically, what happens is they extend off, and the focus doesn't exist on the other side of the lens. The focus actually exists on the side of the lens that the light is coming from, so behind the lens. And again, the center one just keeps going straight through. So if you want to expand an image, like project an image onto a wall, this is one way to do it. You can do it the other way, but if you look, your image will become upside down, because here, so you've got to shoot the image from upside down in the first place, because if let's say this is ray A here, this is ray A there, if this is ray B here, this is ray B there. So you can see that the image will be upside down. Alright, back to here. Again, goes to the center, it's going to be the same. You don't need to write any of this down, this is just for interest. Okay, so here's the human eye. Okay, the creepy little GIF down the bottom there to freak you out if it blinks at you. And we've got normal eye focus. So this is what a lens, this is the lens inside your eye, and it focuses everything to the point on the back of the eye where you see. That's pretty cool. If you are nearsighted, it does this. It just sort of, it closes too early. And so the focal point happens, the focal point happens there instead of right at the back. So you use lenses to make it go a bit longer. And the same if you're far-sighted. So you use this one here, you use a biconvex lens to bring it in closer, to bend it early. Alright, that's it. I hope you got lots of notes. I hope that wasn't too confusing. Good luck. Fill out the form, ask lots of questions in class. Rad.